Now let's take a look at y equals the tangent of 3x. Okay, our a, since nothing is in front of the tangent other than 1, our a is equal to 1 in this case. B, if you look at my standard form of the tangent function, b is always the coefficient before the x, so b is equal to 3, and of course we need b in order to find our period. So the period of this particular function is pi divided by b, which in this case is 3, so pi over 3. Here we go. We're done with the period. The x increments 1/4 times pi over 3 is equal to pi over 12. So whatever we do when we find our key points, we're adding pi over 12 to our starting point and then continue to do this with all the other x values. Okay, the next step, we are in step 4. Let's find the left asymptote. Let me do it over here. The LA. How do we find the left asymptote? You set your argument, the 3x, and in this case you set it equal to negative pi over 2. That will be our first asymptote on the left-hand side. If we divide this by 3, which is the same as multiplying by 1/3, x is equal to negative pi over 6. Negative pi over 6 is our left asymptote. So if I make a little t-table, where can I? There you go. Negative pi over 6 is undefined. That is an asymptote. Now, since my increments are pi over 12, why don't I go ahead and change this negative pi over 6, make it the same denominator? This is equivalent to negative 2 pi over 12. And then it's just so much easier for me to keep adding the increments to it, and I don't have to reduce, I don't have to change anything. So negative 2 pi over 12 plus our first increment, pi over 12, is negative 1 pi over 12. So that's sort of somewhere here in the middle, of course, we're dividing by 2. Then we take the negative pi over 12 and we add another pi over 12, which gives us 0. And it makes sense that it goes through the origin again because we have no shifting to the left or right going on. We add pi over 12, that's pi over 12. Plus pi over 12, which is 2 pi over 12. And I'll show you in a second that this is our right asymptote. You can either reduce it, I usually don't, so 2 pi over 12, which is pi over 6. So let's take a look. The right asymptote, let's do it over here. The right asymptote, to find it, not just by adding the increments, we can also find it by setting 3x equals positive pi over 2. We're dividing by 3, and that gives us x equals pi over 6, which is 2 pi over 12, and that would be our right asymptote. Okay, now let's find the y values. The way I did this with the sine and cosine function, I usually write to the side somewhere my y values for the basic tangent function in this case. The basic tangent function starts off with an undefined, then we have negative 1, then we have 0, then we go to positive 1, and then we have an undefined again. Now, since my a is 1, these values are not changing. I get a negative 1 here, a 0, a positive 1, and an undefined. And let's say here's negative 1, here's positive 1. So negative pi over 12, negative 1, 0, 0. Draw your, I never make the mark. Draw your S-curve, and there is your first period. Now, why don't we graph another period? So we keep adding pi over 12 to it. That would be 3 pi over 12. And then we have 4 pi over 12, 5 pi over 12, and 6 pi over 12. So we have 1, 2, 3, 4, 5 points. This would be my next asymptote, 6 pi over 12. And then I have the same y values, my pattern, negative 1. Then I go through 0, and then I go through positive 1. And if I can draw a nicer S-curve, I would. Here you go. Now I have graphed 2 periods of the tangent function, the tangent 3x.